Let's take a moment to look at bio-driven tooth movements. So bio is an important aspect of what we're going to discuss today with orthodontic aligners. So the concept of bio movements or biometry is to understand the principle involved in tooth movement, especially considering the fact that we'll be looking at orthodontic aligners. And I start with the first term called biokinetics. So kinetics is for movement, is we look at the displacement of the dentition, and in aligner we have what we call displacement driven. So displacement driven is an important concept of tooth movement that has been popularized by the use of thermoformed aligner. And why is it? Because we were doing some staging modalities that are used to this day, or how can my aligners function to correct malocclusion. So we use empirical guidelines for all patients and all tooth movement. It's a displacement driven system where the teeth are moved by the staging. So you have staging from 0 to usually about 30, and you displace the teeth virtually, and by displacing the teeth you are correcting the malocclusion. And why do I say empirical? Is because you look at the guidelines of the companies, they'll tell you, well, you use the 2 degrees of rotation per stage and 0.2 millimeters of translation per stage. Why? It's because experience-based orthodontists have looked at the concepts and said, if I go below that, it's not really efficient, I need too many aligners, and if I go above that, the thermoform aligners will not function, and I will be over the elastic limit and will get no movement and need to refine the treatment. They also have these very empirical movement. When you take conferences, slow down the movement. What does that mean? Well, it means that you may go to 0.01 millimeter translation, or if you have a difficult movement, you may want to use the aligners for 15 days or 14 days instead of 7, which is again an observation. We don't really know which is better. The result of this is basically we get 50 to 60% of the planned movement that is expressed by the aligners. There is a need for attachments and overcorrection or overtreatment, as I think someone from Invisalign once said. So you have to overtreat the malocclusion or overcorrect, which is pretty much the same concept, I would say, to overtreat to get to the results you want to obtain. But it's again very empirical. There is no real science behind it. It's all experience-based. So maybe an expansion and a better understanding of the biointeractions of the aligner orthodontic treatments would be helpful to better understand and to get better outcomes. And what does that mean? Well, we are in the biokinetics, remember? So this is the displacement system we have with aligners. And what we may need to incorporate, first of all, is biomechanics. That'd be the number one. Better understand the biomechanics of tooth movement and what is involved in all sorts of issues such as anchorage control, expansion, torque. All these should be designed towards the better understanding of what really happens at the interface between the aligner and the dentition, to see how we can dissipate the energy for our advantage. The second one is pretty much what is right now getting into a new era, which is called the biomaterials, where you look at the aligner materials, and there are many types of them: PETG, polyurethane, 3D printed, all these materials, and so many materials are now offered in different thicknesses and different compositions, that this is a very important aspect of the treatment with aligners, because if you don't understand the biomaterials, then nothing else really works. And then you have what I call bioregulation, which is pretty much what the PDL and the bone will do. So let's have a look at that. Obviously, I didn't calculate or discuss about the software that are moving the teeth, because I assume that everybody that uses aligners have a significant understanding of software simulations and understand tooth movement. So the biokinetics is now replaced by displacement. This is what we use. We use a displacement type treatment. The other one would be force driven, which is more what you use when you use fixed orthodontics. The biomechanics becomes what type of force system you'll be using. So which is the good force system, according to the laws of Newton, being always an interesting aspect of what we learn. We use a lot of statics in orthodontics, so all these laws have to be mastered by the clinician. The aligner materials also have to be known, and depending on the type of movements you want, you may want to alter or change the aligner materials that you'll be using for a specific treatment of a malocclusion. You may even change the material while you're treating the same malocclusion, depending on the patient's needs. Bone and PDL remodeling, which is again one of the problems that we also have, is this is highly variable and it's patient driven. So if you look at the displacement, this is the delta R, which is the vector of displacement going from 0 to X position. Not very important, but this is the velocity or how much you've been building in the movement, and you can see the T's there all the time, which means that it's very time dependent. So you have to match your staging of the treatment of the malocclusion, which is given to you by the software, to what actually will happen in the patient. So this is really critical. And this is one of the things we don't quite still master or understand, and that may be why we don't get the best result, or the best optimized result, I should say. Then when you go to biomechanics or force systems, you obviously have to control forces with vectors. So you have to understand where the forces are coming with all the definition that you have been taught in school, such as line of action, magnitude, direction, amplitude. So all these have to be understood. You have to understand too that anything you do in orthodontics is a combination of translation, which is the linear force that is applied to the center resistance, and a rotation, which is the rotational tendency of the object, which is in our case the tooth, and they are related by this formula, M equals F times D, D being the distance to the center of resistance of the force that is applied. Something that is very important though in aligner therapy is these two equations where the forces and moments are zero, and you always have to remember that in aligner therapy we use finite elements. It's not finite element analysis, but the aligner is basically englobing all the dentation. All the energy that you've put into your staging has to be dissipated, and hopefully will be dissipated to zero, which is always happening. This is a law of statics, but it has to be dissipated to zero while you are moving the teeth you want to move and not moving the teeth you don't want to move. So it makes a very complex setup. All this together makes a very complex concept that is poorly understood by many clinicians, because they think that aligner therapy is easy, and it's actually not that easy due to the fact that you have to understand the biomechanical concepts to a high level of comprehension. Then these biomaterials, I just put two equations. One is the modulus of elasticity of what you use. You deform your aligner, so there is deformation, and the capacity of the aligner to come back to its shape is very dependent on its modulus of elasticity. It responds to the law, the Hooke's law in thermoplastic materials. If you use 3D printed shape memory polymers, it's different. They behave more like nickel titanium up to a point. We have to get a very good understanding of which material you'll be using, if you use Invisalign, you have one type of material, so you already have this equation kind of controlled, and then it's a matter of you deciding what you want or not use. And again, the resultant at the bone level is good to understand because this is a constant of remodeling. This is another constant that is related to the patient. So depending on the type of bone, this constant may vary. Depending on the patient, periodontal conditions, ethnic capacity, gender, all sorts, age, this will be variable. So you can see that this is highly variable and very hard to control and is never really discussed when you are taking courses on aligners, because at the moment we don't have much science to help us. But be aware of the differences that this bone remodeling capacity and PDL remodeling capacity is in order to adapt your treatment to a specific patient and get the best possible result. So once you understand all these, you can see that our aligners the software has to be well controlled and understood. So the software is there somewhere. You understand and you appreciate what you can do with a specific malocclusion, and then you can go to the other ones, which are 4 systems that are now used with aligner material, and these 2 are then applied to a patient. This is kind of controllable if you understand biomechanics, so it's controllable to a certain point. This is your choice, so you know the physical properties of the aligner. You know that to get this force system on this patient, this is the type of material I should be using. And obviously this one is variable, and what I suggest is called the constant refinement, where you will be adapting your therapy to the patient's response, which is at the moment very rarely discussed. Thank you for your attention.